We began the design phase by reviewing the competition requirements and researching the features of the 14th century horseman's axe. Our inspiration for this design was from several art pieces, statues, paintings, and articles of Robert the Bruce, as well as articles about early age weaponry. Our goal was to balance performance, historical accuracy, and manufacturability while satisfying the competition requirements. After evaluating multiple concepts using design matrices, we opted for a design including a large cast steel head with a shaped cutting edge, a rear spike, and a hickory handle. For our final materials, we decided to use the 4340 cast steel for the head of the axe and hickory wood for the handle.
Our molds were produced by a subcontracted manufacturer in Ohio called VoxelJet. Once the molds arrived, our group traveled to Baycast to complete the molding setup. We built the gates, runners, and sprue using foam patterns secured with nails, and then packed the mold with sand to reinforce the structure. After assembling the cope and drag and bolting them together, the mold was set to cure for 72 hours, but that got extended due to inclement weather conditions. The pouring took place 3 nights later at midnight. Since Baycast specializes in very large casting, our mold system was designed to handle nearly 2 tons of molten steel, ensuring proper filling and solidification.
For the steel axe head, we used a 3-axis vertical Haas VF4 CNC mill to remove excess cast material and bring the head closer to our final weight and dimensional targets. One major operation was pocketing the handle eye area using an end mill to create the internal geometry needed for proper handle fitment and assembly. We also surfaced both sides of the blade region to remove material quickly and uniformly with a face mill in the CNC mill, which helped us control weight while improving flatness and symmetry across the head.
After CNC machining, we transitioned to hand machining to refine the overall geometry of the axe head. This stage included grinding and sanding to smooth the surfaces, shape the cutting edge, and finalize the back spike. After the casting was poured, we faced a major setback when the back spike, an important feature of our geometry, was accidentally removed during cleanup. We shaped a new spike from the remaining cast material, which required adjusting our original design, but kept the tool structurally sound. Additionally, we had to remove a significant amount of excess stop. Using angle grinders and sanding tools, we worked to reach the correct profile and overall mass. Once the final shape and weight were achieved, we returned to Baycast for heat treatment. The head was quenched in oil to obtain the required strength and performance for the competition.
For this handle, we machined the wood profile separately using a Laguna CNC router, which allowed us to shape the hickory blank 4x4 accurately and repeatably before the final hand finishing. Routing the handle gave us better control of fit through the eye and helped maintain the ergonomic profile we designed for grip and balance. Overall manufacturing was a combination of casting cleanup, CNC machining, and manual finishing to turn the design into competition-ready axe.
Baycast completed both visual and magnetic particle non-destructive tests on our axe heads. The circled areas mark small indications found during inspection. All parts passed both inspections under ASTM standards. This means our axe heads meet the acceptance standards and are structurally sound, free of critical defects, and suitable for us to use as intended. We then conducted our own tests by mimicking ones from the previous competitions. We also couldn't resist testing the beheading power of the axe, as Robert the Bruce would have. Overall, the axe held up exactly as we expected, heightening our confidence for the competition. We are fired up to take on the other teams.